Hey guys, so I wanted to go over a couple of different problems from some of the review options I gave you. So the first one I'm going to go over is from it's called the Grade 5 Module 3 Topic 8 quiz or quiz review, and it looks like this. So most of you are now moving on to more of an algebraic way of solving these fraction equivalency and adding and subtracting fraction problems, but it's still important that we are able to show a visual model of how we can create equivalent fractions. So if we see a problem like this first one, number 1, for each represent how we can show 1/5 as an equivalent fraction. This is easier than it looks. We're going to take this model of 1/5, and for example, we could start by cutting it in half. And we know that halves are 2 equal parts, so I'm going to cut it into 2 equal parts, and it's okay if my drawing's not perfect. So now I can calculate 1/5 is the same as how many what? Well, how many pieces are now shaded in this new model? 2. Well, let's use text because that one's going to be wonky. Okay, so we have 2. Out of how many pieces in our new model? We now have 10 because there's 2 rows of 5. So 1/5 is the same as 2/10. And we can continue this pattern by, instead of 2 pieces, cutting it into 3 equal pieces or thirds. And once our model's cut into thirds, we now have, instead of 1/5, we have 3 gray pieces. Out of how many pieces total? Well, I have 5 here, 5, 5, so that's 15. So I know that 3/15 is the same as 1/5, which is the same as 2/10. All of these are the same. And I could continue this over here infinitely. I could do 10 sections, I could do 4 sections. The pattern just continues. So you cut your image across the middle horizontally because our existing lines are vertical. So we're going to make horizontal cuts. And it's just up to you how many cuts you make, as long as you put the shaded pieces in the numerator and the total pieces in the denominator, you're going to come up with an equivalent fraction for 1/5. Now we're going to scroll down to number 4. Let's talk about 4 because it's a word problem. It says Grace cut 3 pieces of ribbon. Each piece was 2/5 of a foot long. How many feet of ribbon does she have in all? Express your answer as a mixed number. So we cannot leave our answer as a fraction greater than 1. If we get a fraction greater than 1, we need to make sure we stop and take the time to turn it into a mixed number. Draw a number line to represent the problem. So we know that she has 3 pieces and that each piece was 2/5 of a foot. So I know the first thing I want to do as a 5th grader is start writing my equation. What am I going to do to solve this problem? And then I can start thinking about how I want to show it or represent it. So I know that I have 2/5 happening 3 times. I'm adding because I'm finding the total. How many do I have in all? The first thing I want to do is check, do all of my fractions have the same denominator? If the denominators are the same, I can go ahead and add my numerators across the top. In this case, yes, they all have the same denominator. Each piece is already the size of a 5th. So my denominator stays the same. Then I come here and I add my numerators across. 2 plus 2 plus 2 is 6. So my answer is going to be 6/5. However, the problem did ask me to show my answer as a mixed number if it was a fraction greater than 1. So I'm not going to leave 6/5 as 6/5. I'm going to turn it into 1 whole and 1/5. How do I know that 6/5 is the same as 1 and 1/5? Well, I know that in each whole, there are 5/5. So if I go from 0 to 1 on a number line, and we're cutting it into fifths, each whole is the same as 5/5. If my answer is 6/5, then I know that that's going to be these 5/5 plus one more. 1 1/5. It'll cooperate with me one of these days. There we go. All right. So number 5 is great practice for us to figure out how to turn fractions greater than 1 into a whole number. And there's just a real quick basic step to do to get this right every time. If you recall, we learned that fractions are division problems and that the fraction bar says out of. So if you have 8/5, you have 8 out of 5 that you need, which means you're going to have enough to make one whole group and you'll have some left over. So if we start thinking of these as division problems, 8/5 is asking yourself the same thing as how many 5s can you make out of 8? Well, if I have 8 of something, can I make one group of 5? Sure, I can, and I'm going to have 3 left over. Is that enough to make another group of 5? No. So I was able to make one group with 3 pieces left over. Remember, the numerator tells you how many pieces. And my denominator is going to be 5 because your denominator tells you the size of your pieces. So now let's try that over here with 12/13. How many 12s are in 13? Well, if I have 13, can I make a group of 12? Yes, I can. I'll have 1 left over. So I can make one whole group with 1 piece left over, and that piece is the size of a 12th. Now let's try one that requires us to think a little bit harder. Let's come over here to 23/8. We're going to use the same strategy though. How many 8s are in 23? Well, this is one where the numbers aren't very close to each other, so I know I'm definitely going to be able to make one group and probably more than that. So I'm going to start thinking about my multiples of 8. 8, 16, oh boy. Here, let's use text boxes. Okay, so listing those multiples of 8. 8, 16, 24. Oh, I noticed that 24 is too much. So that tells me that I'm going to be able to make 2 groups. These 2 will work, so that's 2 groups. That'll take me to 16. 23 minus 16. Let's see if this 6 is going to work or if it's going to do something funny. Is 7. So my answer is going to be 2 and 7/8. I was so close to making 3 wholes, but not quite. So now over here for 33/4, we're going to again take the same approach. How many 4s in 33? We'll start by listing our multiples of 4. And if we do that, we get 4, 8, 12, 16. Let's move this over just a little bit. 20, 24, got to keep going, 28, 32, 36. All right, so once I go over, I stop, and I'm not going to use that one. So that means that I can make, let's count them, 1, 2, 3, 4, 5, 6, 7, 8. I can make 8 groups because I can't use this last one. That gets me to 32, and I know that 33 minus the 32 I made is 1, so I will have 1 piece left over. So my final answer will be 8 and 1/4.